Waterloo Moraine is a very large feature in the area that formed during the deglaciation, during the drawdown and retreat of the Laurentide ice sheet. And it created a positive relief feature that consists of several different hills and other type of features, and it formed during deglaciation at a time when there was a lot of meltwater. The ice sheet was also drawing down, and there was a lot of debris-rich ice that was being exposed, and running water at the surface of the glacier, running water inside the ice and at the bottom, was able to pick up material that was melting away from the ice, and that material moved with the water and accumulated in different depressions, sometimes even on the ice itself. And so a lot of sediments were deposited around the ice that was getting thin, and so these deposits are called ice contact deposits because they were first initially deposited when there was ice around, and quite often also even under as well. And so when ice melts away and it melts unevenly, those sediments will eventually sort of collapse progressively, and they found themselves on the ground and form this irregular topography. The hills that we see behind me are called Kames. So those are formed again in that same way. There are ice contact sediments deposited in depressions, and when you remove the ice over time, when ice is removed over time, they are left behind and forming piles. It's just like if you take a bowl of cereal, you fill your bowl with cereals, and if you remove the bowl, the cereal will be left on the counter and forming little mounds and little piles. So this is at a different scale, but it's the same kind of idea, that sediments were filling depressions in the ice, sometimes on top of the ice, inside the ice, and so on. And upon melting, once the ice is removed, they lose the ice support and they form all kinds of different mounds on the surface. Very heterogeneous sediment as well. Lots of silt, sand, gravel, and even sometimes as well like till lenses and things like that. So these are called Kames, and they're ice contact deposits. We have a lot of these things in the Waterloo area around the Waterloo Moraine. But the Waterloo Moraine is a very complex deposit. There are also other type of sediment assemblages, other kinds of landforms. So this is one example of something that's quite common on the Waterloo Moraine that resulted from the drawing down of the ice, the thinning of the ice, exposing lots of debris-rich ice with running water, picking up the debris that are released by the melting. And all of this is transported and deposited in different depressions on the ice itself. And because of the uneven melting and redeposition of these material, there's a lot of internal deformation as well in these sediments. And all that happened during deglaciation, when ice was getting really thin, and under the influence of topography, there were still big lobes of ice that were flowing along the Lake Ontario area basin, depressions, as well as Lake Huron and Georgian Bay. So those are called Lake Huron, Georgian Bay lobes, as well as Ontario area lobes. And those lobes were sort of flowing around, and this area here in the middle, the Waterloo region, at the time was sort of, in terms of the ice sheet and the ice margin geometry, it was sort of unzipping in the area and opening up the space for sediments to be deposited. But for quite some time, there was still ice in the area. It's just it was like a saddle, and a lot of material was being transported and deposited in this depression. And as I said, it's called inverse topography. You fill a depression, but once you remove the support, you remove the ice, all the sediment that was accumulated there, eventually become a big mound, a big pile of things on the landscape, right? Just like an inverted bowl of cereal, if you wish. Okay, so this is the Waterloo Moraine, a very large feature consisting of heterogeneous material and covering a large area of the Waterloo region. the Waterloo Region. It's an important resource for aggregates, as you can see, and so it's important to manage the moraine properly, because there are also a lot of other activities. We're building the city on the moraine. We're also using the water resources, the aquifers of the Waterloo Moraine. So a lot of different activities. Study and understand the geology of the Waterloo Moraine. Perhaps this is something that some of you will eventually do as geoscientists, is to work on the moraine, learn, better understand its geology, and help manage the resources for the Waterloo region.